Okay, so there are several different operational properties. We're calling these the properties of real numbers. All of the definitions are already listed for you by each type of property. The ones we really focused on last year were commutative and associative, and we talked a little bit about both. I know that you've been talking about these since at least 4th grade math, maybe 3rd. I can't remember when it was first introduced, probably even before that, but maybe you just didn't know the actual names for it. So we're going to review each one of these, and we're going to do an example so that you have completed examples in your journal too. We're going to spend a little bit more time on distributive properties, so we're going to leave that blank for now, and then we'll come back to that another day, because we're going to spend an actual day of taking notes on distributive property and practicing with that, because it's a little different. Okay, so looking at the first one, it says additive identity. First of all, the word additive, what do you think we're dealing with? Addition. So it says when 0 is added to any number, the sum is the number. So that basically just means if I have a problem that looks like this, then it should still equal 5. But I also have the multiplicative identity property, which is similar, but basically when any number is multiplied by 1, the product is still that number. So the number isn't going to change based on multiplying it by 1. So that'd be like if I had 7 times 1 is still 7. I could also show it like this, remember, in parentheses, and then I can also show it with a little dot. You don't have to do all of those unless you just want to have those examples. Okay, I then have the multiplicative property of 0, which means that anything times 0 is just going to be 0. The commutative property of addition means that the order in which numbers are added doesn't change the sum. So I could have something like 1 plus 2 plus 3, and it's going to be the same thing as if I were to do 3 plus 1 plus 2. It doesn't matter the order that I add them in. It just matters that I add them all together. The commutative property of multiplication, this one's similar. So it says the order in which numbers are multiplied does not change the product. So similar to the addition one, but instead of adding, I'm doing what? Multiplying. So it would be like 2 times 3 times 4 would be the same thing as doing 3 times 4 times 2. You can group them however you want as long as you still multiply them all together. Associative property is very similar to commutative, but you are throwing in some parentheses. You're grouping. You're showing which ones you're going to do first. So if it's associative property of addition, that just means the order in which numbers are grouped when adding does not change the sum. So that'd be like if I took my first example, 1 plus 2 plus 3, and I decided to group 1 plus 2 so that I do that first, then add 3. I would still get the same answer if I just did 1 plus and then grouped 2 plus 3. And I did 2 plus 3 first and then added 1. Based on order of operations. You're still going to get the same answer because you're still adding everything together. It doesn't really matter which one you do, but it does tell you, because of the parentheses, where to start. Same thing with multiplication. The associative property of multiplication is the order in which numbers are grouped when multiplying does not change the product. So it'd be like if I had 2 times 3 times 4 versus 3 times 4 times 2. All I'm doing is flipping things around and grouping different numbers to multiply first. Okay, again, distributive property is what we will do later this week. We're going to spend an entire day on that, but we're just going to practice all of these today.